Chapter 5, in-class exercise 0. In your handout, this is written as in-class exercise 1. Let's change it to in-class exercise 0. So let's work on it. The question is to identify forces acting on the rigid body and draw them on the free body diagram. So let's work on it here. So these are different examples. So for each example, we will identify the different forces, including the weight or support reactions. For example, the car has center of gravity G, then one of the forces is the weight of the car which acts vertically downward. And by the way, for all the examples, we assume that all objects are in equilibrium. That means they are in stable condition. They are not moving, they are just there. So car is not moving, car is in stable condition. So then the support reactions are coming from the tire. So there are 4 tires and each tire has like force coming from supporting force acting from the ground onto the tire. So these are support reactions. For the example of this aeroplane, which is also in equilibrium, the support reactions are 3 support reactions at 3 tires coming from ground, because these tires are actually supported by ground. So ground exerts normal force on those tires. And the plane has center of gravity, which is somewhere here, and the weight of the plane acts downward. So these are the different support reactions. For this book, weight of the book acts downward, but then there is normal force acting from the table in the upward direction that prevents the book from going further down. So that's the free body diagram. We already talked about the ramp example. So for ramp, these are the support reactions, different forces and support reactions. So weight of the ramp acting through center of gravity. This cable has tension force T, and then this pin here has horizontal and vertical support reactions. For the platform, the support reactions are forces at pin, so horizontal and vertical support reactions, AX and AY, weight of the platform acting through center of gravity, and tension force in the cables T. Okay, so these are the different support reactions or forces. For forklift and this pipe example, the support reactions are pipe is being supported at 2 points. So there are 2 support reactions, and then the weight of the pipe acts downward. So that's the free body diagram. For this object, if it is in equilibrium, weight of the object is that acts downward, then the normal force is perpendicular to this area of the surface of the contact, and that's it. Those are the 2 support reactions for now if an object is in equilibrium. For this pipe assembly, the support reactions are it's being supported at A. So this concrete block exerts the force in the opposite direction. It's being supported at B. So that's another support reaction. So this is AX, this is BY, Y because it's in the vertical direction, and then this is CY. So these are 3 support reactions. And we already talked about this in the presentation. So there is 1 support reactions coming from roller. So roller only prevents the motion in this perpendicular to the roller direction. It allows the motion in the other direction freely. So this assembly can slide freely. However, it cannot rotate as well. So there's 1 support reaction, linear support reaction, and there can be another one that prevents the rotation. For pin, the support reactions are horizontal and vertical, AX and AY. For fixed, the support reactions are 3, AX, AY, if this point is A. And then there is rotation, MA. So there are 3 support reactions. So that's it for in-class exercise 1. Oftentimes, this roller can also be drawn like this, just one round roller. Okay, so this and this are the same. Okay, so there are 2 different ways of drawing roller. But pin is very clear. When we draw a triangle like this and circle, that's pin support. So which allows the object to freely rotate, but it does not allow any translation. And that's the fixed support.